Thank you, everyone, for coming here today to watch my talk about accessibility and interactive canvases. So, just a real quick introduction. My name is Oli. I'm a former game developer. I have worked with Lara Croft and Sonic the Hedgehog in the past. Great people, by the way. I love them. Nice people. And so now I work at a company you may have heard of called AG Grid. And I work on the team which does the charting component. So here, this is basically our website. I'll just quickly show you what it is so that we're all on the same page. So essentially, yeah, it's a framework-agnostic library for drawing charts, such as bar charts like this. We also can draw financial charts. We also have some map charts here as well. All different types of charts. One of the key features of our library is that it is rendered using a HTML5 canvas as opposed to an SVG, which is what most other charting libraries uses. There are some few exceptions. So as you can see, like this toolbar here, those are just regular HTML5 buttons. But specifically for this talk, I'm going to focus on the canvas rendering part of AG charts. So the problem space that we're dealing with is when you're rendering a chart, the big question is, should I be using an SVG image or should I be using a canvas? I'm sure most of you are already familiar with the concept of these two, but just to make sure everyone understands, let's quickly go over the two, like the pros and cons. So an advantage of the SVG is that, so that's basically a vector-based rendering system. It's rendered by your layout engine like Chrome or Safari. And it has an XML hierarchy where all of the shapes and everything are defined by some XML tags. Canvas, on the other hand, that's just a single HTML element. And the JavaScript developer is responsible for writing all the rendering logic for actually drawing the code. And so you don't have a hierarchy. You just have that single element. The two are basically very, very similar to one another. So as you can see, these two images, they're exactly the same image. One of them is rendered by an SVG where you say, OK, I want a circle here, I want a rectangle here, and I want a polygon. Same thing here with the canvas, but it's written in JavaScript as opposed to XML, where you're saying I want a circle, a rectangle, a triangle, and so forth. And so the main advantage of an SVG is that because you have these XML tags inside your DOM, you can basically, as I'm going to show you right here, if you inspect here, you can set some additional attributes onto the elements. So for those who aren't familiar, there is this concept called ARIA, where you can basically say, for example, raw button. This will tell the screen reader to treat this element just like if it was a regular button. Let's try to see what happens now if we turn on the screen reader.
VoiceOver on Safari, comparison. Button, less than, button, 3 items, button, button, button. You are currently muted.
So, as you can see, because now I've set those roles on those XML attributes, the screen reader is able to pick it up and says, OK, these shapes are actually buttons, so I'm just going to treat them as buttons. Then you have to add other handlers like the keyboard and mouse input handling. But you can basically tell the screen reader, here, this is what the buttons are. We cannot do that with the canvas because it's just that single element. So how did I get around this? Well, basically, the solution that I found was to just, quite simply, hide the canvas. Well, not completely hide it, obviously. We still draw it on the screen. But there is this attribute called ARIA hidden. We set that to true to tell the screen reader, just don't pay attention to this canvas. Nothing important here. And then what we have is we've got this concept called proxy elements. And that's essentially just some HTML elements on top of the canvas, but they have transparent background, or they're not drawn. They're there in the tree, and they're there in the DOM, but they're not drawn. So like if I were to show you here, I can basically mimic the same result I had before with the SVG. If I were to go here we can do the same thing we had before. Let's set the role to a button. Now let's do the same thing as well with the other ones. Yes, here we go. And then here as well with the triangle for completeness. Cool, now let's go back into full screen and try this out.
ARIA hidden, true, heading level 1. The solution, hide the use of after, button, 3 button, button. You are currently on a button inside a group.
So
To click this button, press Control button.
That is the core of. Oh dear, that is not what I wanted to do.
Safari dialog.
Sorry about that.
Voiceover off.
Okay, cool. Yeah, so basically, that's the core of how I've implemented accessibility on a canvas. It's just basically completely hide it and re-implement the entire tree and say, this is where all the stuff is, basically. So let's talk a little bit more about these proxy elements. What are the key elements of it? So the most important thing is you must not set the display to none, and you must not set the visibility to hidden, because these two properties actually remove it completely from the DOM, and they remove it from the accessibility tree, and then your screen reader is just going to ignore that completely. So we don't want that. Instead, what we want to do is you want to set like a transparent background, so like opacity 0, or you can set background to just transparent and make it a transparent color. Then another thing you want to do is you want to make sure that your proxy elements will have a focus indicator. This is important because some of your users may not necessarily be using a screen reader, but they still require you to use the keyboard. You can think of someone, for example, who has like perfect vision, but they've got some sort of mobility impairments. And so it's important to make sure that we also style it, to make sure that we have like some focus indicator to tell the user what they're currently using. And then the main positioning we want to use is position absolute with a container that's common with the canvas, so we can make sure everything aligns up properly. So here, I'll show you an example. I've set here this property here, focus visible, and that tells it to show it when I'm using a keyboard, but not when I'm using the mouse. So here, if I were to click on here, you see it says I've clicked a square, I've clicked a triangle, I've clicked a circle. But if I then press the tab key, here, my browser automatically detects, oh, now you are a keyboard user. So it's started showing the focus indicator around it. And if I press the space key, then yeah, then it basically clicks as I want. If I turn on the screen reader,
voiceover on triangle.
It also properly tells me triangle, square, circle. In this example, I also added some text to these buttons so that it actually tells me what it is that's going on. Let's have a quick look with an AG chart. So here is a very, very simple chart. I say very, very simple because it's not actually a chart. It doesn't have any data. But the reason we don't have any data is that we don't really use this technique for the data. We use a slightly different technique that I'm going to get into. But we do use this technique for the legend. So that's what I'm going to demonstrate. So as you can see, if I press, I can basically click these and something happens. Well, nothing really happens. It just fades in. But yeah, I can click these buttons here. I can also use it with the keyboard. As you can see, there's a focus indicator that's telling me which element I'm currently using. And it works very well with the screen reader as well.
Voiceover, next legend page, button. Now search text field.
Oops.
You are currently, find the downloads.
No, thank you. Don't look, that's
dialogue.
confidential.
Next search text. You are currently on a mission
No,
control.
close your eyes, close your eyes, close your
Safari,
eyes.
dialogue, entering legend, leaving next
There
legend
we go.
page. But search text field. You are currently on find
Okay,
a search
I think it's
mismatch.
because someone,
Safari image.
okay, basically
previous
if you
legend
press,
page, button. You are next legend, previous legend page.
there we go,
dimmed,
there it
button.
says dimmed,
You are
as
currently
you
on
can
a button.
see.
Next
This
legend
one,
page.
it says not
button.
dimmed.
Previous entering legend
and then you go
series
here.
6.
Every time
Legend
that I
item 6 of
press-
third off, on, series
On, off, on, off.
off,
Okay, now you shut up before a bit, let me talk. Okay. Yeah, so basically, as you can see, I think you've sort of seen the concept. Every time you move around, the screen reader talks very, very assertively, like, this thing is going on, this thing is going on. But that's actually very good, because if you've ever seen a blind person using a computer, this is the madness that they have to deal with, just like, blah, 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 blah. So that's good, that's nice. We've got a very responsive screen reader that responds to the input and output, so that's very good. So like I said, like that chart didn't have any data. And the reason for that is that these proxy elements, they work well for UI components that don't update much and they don't move around so much. And they work very well for UI elements that already have some sort of area predefined semantic in the spec. So that example that I showed you, the legend items, those are just switches, which is a button that also has an on-off state. And then the pagination button, left, right, those are just regular buttons. So it works very well for that. Wait, oh, someone's sending me a Slack message. Okay, ignore that person, that's not important. But it doesn't work very well if you want to have like a completely customized control. That's one of the advantages of a canvas is you can kind of draw whatever and just make up new controls. So let me show you a very simple example. So here I've got this new UI control that I've invented. It's called the ball. It goes to the right, and it goes to the left as well. So that's all it does, basically. It's a very, very simple control. But let's see what happens when I turn on the screen reader.
Dialog. Interactive canvas. New position 3. Position 7. Position 2. Image. Position 1. Image. Voiceover off.
Okay, that's a very, very straightforward example, but it's pretty cool. Every time the ball moves, it tells me position 1, position 2, position 3, 3, 4, 5, 6, position. So that's nice, cool. It's like every time the ball moves, immediately the screen reader is telling me what's going on. That's nice. So what's going on here? So basically, the trick that I'm using here is that I'm treating the screen reader announcements just like a video stream. Like I said before, I'm a former game developer, and so if you're not familiar with how video rendering logic works, we typically will use a data structure called a swap chain, which is basically just two images. So one image is drawn onto the screen, onto the display, and another image is hidden somewhere in the back, and the graphics card will be drawing on that image. And then when the next frame is ready, you swap around the purpose of those two images. That new image comes shown in the front. Then the old image can be reused, and the graphics card can then draw the next frame. That's the exact same concept that I'm using here. So I've got two proxy elements. I've got one that's always visible to the screen reader, and another one that's always hidden. But it's there, it's ready. I can update the text value and make that one visible whenever I want. And the method that I use for swapping these buffers is the focus method. The reason why this works very well is that, well, first of all, a canvas, you can kind of conceptually think of it like a video feed, because basically you draw something, and after a certain amount of time, maybe after a few milliseconds or after a few hours or whatever, it draws another image. So it's kind of like a video feed in a way. So this mechanism we're using, it syncs up very well with the update pattern of the canvas. And another thing that I noticed is that assistive technologies such as screen readers, they handle focus changes very, very, very well. Like I had tried different approaches, such as using an ARIA alert or having an ARIA label that you update occasionally. But there was always that odd one out, that odd browser that wouldn't work, or that odd screen reader, or that platform. Like there was always something somewhere not quite working. But the only thing I found that works very, very reliably is focus changes. This works on every single browser, on every single screen reader, and on every single everything that I have ever tested. So let's kind of have a look at this demo a bit to understand what's actually going on. So let me just walk you through the code. So here we've just got some input handling, and we draw the ball. The rendering logic isn't important, so I'm not showing that. And then what we do here is the actual swapping. So we swap around the purpose of these two proxy elements that we've got. And then what I do is the new one that's about to be shown, I update the text value, the ARIA label of the announcer, and I set it to visible. And then the other one, I set that to invisible. Maybe let's make it hidden. And then we do the focus, which is actually the swap. And so let's have a look at what happens when that moves around. So the first thing you want to look out for is this style property. You'll see one of them is always on display block, which means visible, and the other one is on display none, hidden. As you see, as I move left and right, these keep switching back and forth, block none, block none, block none, block none, block none, block none. The next thing you want to look out for is this text value. So I always have to update the text value of the next one I'm about to show. So here, if I want to go to the right, I need to update this to position 2. Now that becomes visible. I want to go to position 3. I have to update this one, position 3. But, oh, I pressed the wrong button, that's why. OK, position 3. Then you press again. That one goes to position 4, and so forth. And so that's basically the mechanism we've got. We've just got a stream of announcements that we keep swapping back and forth, and so they will assertively keep announcing things. That's very cool. I like that. That's nice. We've got a really good product here. But we can do better. As I've said before, it's very, very important to make sure we have a focus indicator. So we can use that focus visible property that I was mentioning a while earlier. Just a quick reminder, the focus visible pseudo class, what it means is, if you read the spec, it's like loads and loads of lots of words. But roughly what it means is like hide all of this stuff for a mouse user, but show it for a keyboard user. More or less. That's more or less what it means, right? So we're going to use this pseudo class and add some stuff in there to show a focus indicator. And we can use any kind of shape we want. A square, a rectangle, a circle, a Pikachu, anything we want. Like, it's amazing, it's great. Let's have a look at that. So here we go. Same demo as before. The main difference is, you see, I've set my announcers to be invisible, opacity 1. However, when focus visible is enabled, I want that to be visible. Then I've got some styling here for a focus indicator. And what I've done here with my announcers, the only difference is I've added this child element, which is the focus indicator, which means when one of these announcers comes into focus, if necessary, we will also show a focus indicator. So basically, if I were to click this with the mouse and then move left and right, this is the same thing as before, but nothing really is happening because I'm using the mouse. But you will notice that here, these bounds are being updated. And that's because I'm updating the bounds of a focus indicator that's currently not shown. But if I click here and then I press the tab key, wow, look at that. It's a circle and another circle. Wow, that's cool. So I move this around, and then it tells me exactly what it is that I'm manipulating. That's very, very cool. I mean, here it's kind of pointless because we've only got one ball. But if you were to use your imagination, what if we had like thousands and thousands of balls everywhere? Like, how would you know which ball you're moving? You would have no idea. But now, we know, because we've got that little focus indicator around the ball. And it's not a square, it's a circle. That's so cool. Like, I didn't even know we could do that, but we can. So yeah, let's have some quick examples, real-life examples, not just some boring ball. Let's see what we can do. So here, let's turn on the screen reader as well.
VoiceOver on Safari.
So wait, let me
Dialog,
first show you
VoiceOver
how it would be without a screen reader. So you can click here to enable, disable some series. If I click on a thing, it tells me this thing has been clicked. Yes, OK. And with the screen reader as well, I can do the same thing
VoiceOver on
with the keyboard.
You are currently next legend page, but image. Entering legend content, leaving 2017.
Then I can press the space key and it
1.798K image.
The clicked value.
You are currently on entering legend leaving legend 2018, 2019.
And I
entering
can come
legend
here and
offshore
hide these things.
landfill, leaving
And every time I move,
2017.
You see, as I said,
2000,
the thing that's nice is that the screen reader is very, very assertive and responsive. Like, there's never a case where it's like not announcing something or it's waiting for some other announcement to end. As soon as I press anything on the keyboard, it will cut off what it's doing and announce what's the most recent state. And that's good, because that's exactly how you want to make it as accessible as possible. Because like I said, someone using a screen reader, they'll just be like going all over the place. You gotta be quick. You ain't got no time to waste, all right? So yeah, that's very, very cool. Let's try another example. So here, we'll like a good
VoiceOver off.
we'll like a good, a pie or a donut, pastries. I'm more of a croissant guy, or I'm Belgian. We say coucou chocolat as well for like little bread croissants.
Web content.
No, wait, not bread croissants. It's a bread. Yeah, whatever. That's not important. That's not important. But basically, the main thing I want to show you here is that we really can make a focus indicator any shape we want, right? Okay. So if I were to hover over these things here, you can see, okay, the canvas is being updated. We're updating the frames because you can see that the highlight is changing. Okay, that's cool, that's cool. But if I come in here with a keyboard, whoa, cool, look at what it's doing.
Commodities.
Look at that focus. Oh, that's like a little sector thing. And that's like a little triangle with an arc thing. That's so cool.
60,000 image.
And we do this as, no, shut up, thanks. So we do this as well with the maps. So like if you've got a map of the USA, the focus indicator will go like everywhere. And they will do the same thing with like Brazil and then Africa and everything. And it's so cool. Any shape you want, you can do that. Because we just use an SVG image, we set that path. So that is essentially, in a nutshell, that's kind of how we have got a canvas that's accessible. There's a lot of more details and like little nitpicks here and there, but that is the gist of how it works. So I'd be happy to answer any questions you have. That's the QR code that you can or cannot scan, up to you. It's the source code for this specific slide deck that will show you exactly what's going on. The code is a little bit messy, but who cares? Whatever. We're learning here, right? We're learning. So yes, that's all. Please feel free to ask me any questions.